Now, you've been told to, example 4, you've been told to simplify the following expression, giving your final answer as an integer. Part A, log 3 to base 2 minus log 24 to base 2. So can we start with that part A? So that part A, what do you see? It is direct. Same base with subtraction. It means we use this law of logarithm, isn't it? So part A we have log 3 to base 2 minus log 24 to base 2. So here, if you have the subtraction, it means when you have log x over y, that is the same as log x division means minus log y, isn't it? So the base here is 2. So you put base 2 for everything because the base must be the same for everything. So from here, it means when we have subtraction, it means our x is 3 and our y is 20, isn't it? So where there is x, we put 3, where there is y, we put 24. So it means when we have log 3 to base 2 minus log 24 to base 2, if we remove log to base 2 outside, subtraction changes to division, isn't it? So that we now have 3 over 24, isn't it? So what is 3 over 24? 1 over 8, isn't it? So that is log to base 2, 1 over 8. 1 over 8 is the same as 8 raised to negative 1, isn't it? Because 1 over 8 is the reciprocal, isn't it? Negative 1 means reciprocal, isn't it? 1 over 8 is 8 raised to negative 1. But what is 8? You can express 8 in terms of 2, isn't it? Are we together? So 8 is the same as 2q. So lots of indices, a power outside multiplies with a power inside. So there we have log 2, 3 times negative 1 is raised to negative 2 base 2, isn't it? So negative 3 is that coefficient. Good. So if you put negative 3 coefficient, you end up with your final answer is negative 3, because log 2 to base 2, a log of a number to the same base, this negative 3 becomes the coefficient here, isn't it? So a log of a number to the same base is 1. Log 2 to base 2 is the same as log 2 over log 2, which is 1, isn't it? So the final answer is negative 3. So you are done with part A of that problem. Then you move to part B, isn't it? So using the same procedure as you've used in part A, can you now work out this part B? What have we said? When you have 1 over A, that is the same as A raised to negative 1, isn't it? So we can start with that case. So here we have log A squared to base A minus 4. Log A, 1 over A is the same as A raised to negative 1, isn't it? Then you get rid of the powers, isn't it? Are we together? Or before that, we join them. We remove this negative 4, we get rid of the coefficients, that is the first thing we do, isn't it? So this one is what? Log A squared to base A, negative 4 becomes the power, isn't it? Isn't it? So negative 4 becomes the power, you remain with, or you can leave it as negative there, doesn't matter. So negative 4 goes to the power, isn't it? So if 4 goes to the power, you get, this was negative 1, a power outside, then it is raised to power 4, isn't it? You've only taken 4, you've left negative, isn't it? So a power outside times the power inside, 4 times negative 1, you get the power there is now negative 4, isn't it? So you now don't have the coefficients, meaning you can now remove log to base A outside because you must have the same base for you to use the laws of logarithm, isn't it? So if you remove log to base A outside, here we have A squared, subtraction implies division. Then A squared divided by A raised to negative. So what is A squared over A raised to negative 4? Laws of indices. Same base, you subtract because of division, isn't it? 2 minus negative 4 is 6, isn't it? 2 minus negative 4 is 2 times plus 4. Isn't it? So here we have log to base A of A plus 4 because 2 minus negative 4 is positive, isn't it? So 2 plus 4 is 6. Now that 6 becomes the coefficient, isn't it? So there you now have 6 log A to base A. A log of a number to the same base is 1. So you remain with good. So That is how to sort out a problem like that.